All right, back again with more AP Stats review. Let's go ahead. We left off on number 18. When using a one sample T procedure, either confidence interval or test, to construct, a confidence interval for the mean of a finite population, not infinite. A condition is that the population size be at least 10 times the sample size. The way we phrased it is that it's less than 10% of population is saying the same thing. So the reason, just to give you a little context, the reason we have this condition that our sample has to be less than 10% of a population, if we have a finite sample, something like if we wanted our population to be all trail students as a population, not a sample, then we have a finite population of around 1,300 students. The thing is, if we're taking that sample of students, we take them from the population, we sample them, and then we put them back into the population. Let's say that I had a sample of maybe, let's say, n equals 100. The thing is, once I sample that student, put them back in the population, there's still a chance that I could, with my next person I'm sampling, that I could take that exact same person again, which would be bad for our sample. So in order to consider if this is valid or not, we want a big population, 10 times the size of our sample, so that it's large enough that we're not taking the same person repeatedly. And the best way to interpret that is D right there. 19. A nonprofit organization holds a raffle to raise funds for its operations. A total of 1,000 raffle tickets will be sold for $1 each. After all the tickets are sold, one ticket will be selected at random and its owner will receive $50. Expected value for the net gain of each ticket is negative, so you're expected to lose 95 cents on each ticket. Or not you, but the ticket owner is expected to lose 95 cents for each ticket. What does expected value mean? Well, first of all, the ticket owners lose an average of 5 cents? No, they lose more than that. Actually, they lose about 95 cents a ticket. It doesn't mean each ticket owner will lose 95% because one ticket owner is going to win $50. A ticket owner would have to purchase 19 more tickets for an expected value to increase to zero is not true, because if you buy 19 more tickets, you are just expected to lose more. And E, I don't know where they're coming from with that. 20. Suppose on a hypothesis test for a single population mean, the alternate hypothesis is that the population mean, is less than 10. Assume that the alternate is true, that the mean is less than 10. For a fixed sample size and significant level, the power of the test will be greatest if the actual mean is which of the following. Now, power is the ability to reject false null. So, which one will give you the most ability to reject a false null? So if the alternate is that, we can guess that the null is that it is 10. We already know this actually is true. So really quick, you can't, it says the mean is less than 10, so all these more than 10 or equal to 10 are wrong. So the one that actually will make it easiest to disprove is the one furthest away, the mean furthest away from our null. 21 should be really easy. I'm not going to spend time reading it. You should be able to read a residual plot and show me what random scatter looks like. 22, a random sample of 50 students at a large high school resulted in a 95% confidence interval for the mean number of hours of sleep per day is between 6.73 and 7.67 hours. Which of the following statements best summarizes the meaning of a confidence interval? Remember, confidence intervals start with a statistic, and then you have a margin of error on both sides. And then you can take another sample, which wouldn't be the same as, well, it doesn't have to be the same as the first, and margin of error on both sides. Another sample, reach on both sides. So the thing is, you can take many, many confidence intervals, and you guess that somewhere in the middle, somewhere where they all overlap, or most of them overlap, is where that true population mean is. Now, sometimes you get a sample that's not drawn right. Sometimes you get a sample and it just misses it. So not all of them do. That's why we say we're only blank percent confident. So the best interpretation here is between A and B. So decide between A and B because anytime they're saying 95% of students, this is not talking confidence, this is talking probability. And 95% of the time is also a dead giveaway that they're talking probability there, so you can eliminate those. The better interpretation is between A and B. I'm going to let you decide which one that is. Hint, it's not A. 23. All right. So a local company is invested in supporting environmentally friendly initiatives such as carpooling. Blah, blah, blah. The results are shown. Which of the following statements about a randomly chosen person from these 200 companies is true? If a person owns a car, so car ownership, yes. He or she is more likely to live elsewhere in the city than to live in downtown. Compare, decide. If the person does not own a car, he or she is more likely to live outside the city than to live in the city, so doesn't own a car, more likely to live outside the city than either of those. Compare, decide, do with the rest of these. 24, a random sample of 432 voters revealed that 100 are in favor of a certain issue. So that means the proportion would be 100 out of 432. That's a p-hat. So eliminate 3 of those off the bat. So gone, gone, gone. It says a 95% confidence interval. Tell me which of these two Z's, I shouldn't have even told you that, but tell me which of those two correspond to a 95% confidence. 25, the commuting time for a student to travel home from a college campus, this should be pretty easy, is normally distributed with 30 minutes and standard deviation of 5. Basically, you can keep building this. If a student leaves home from 8:25, no later than 9, how many minutes is that? So that's 35. This is a basic z-score or normal distribution probability. In 2009, a survey of internet usage found that 79% of adults ages 18 years and older in the United States use the internet. I bet it's probably gone up since then. A broadband company believes that the percent is greater now. What do you know? Than it was in 2009 and will conduct a survey. The company plans to construct a 98% confidence interval to estimate the current percent and wants the margin of error to be no more than 2.5 percentage points. Knowing this, I can eliminate 2 of these right now with 0.05 because right here, these are all consistent with 2.5 percentage points on margin of error. Assuming that at least 79% of adults use the internet, which of the following should be used to find the sample size needed? You don't actually have to find it. But the issue, we should be using p-hat, q-hat over n. We have a p-hat, so there's no reason to be using 0.5. Remember, 0.5 is if we don't know a p-hat. Worst case scenario, use 0.5. But if we have a p-hat, then we should be using it. I'm going to start 27 on the next video. Hasta la bye-bye.